Right, let's get this party started. All right, hello everyone. Woo, let's do this. Feeling pumped. So excited to be here. Right, thanks for starting that. Can't believe it. PyData Paris. My name is Marco Gorelli from Quantsite Labs. I work mainly on Dataframe related things, API design and stuff. And I'm here to tell you about how you, yes, you, can extend polars using plugins, and how this is easier than you might be thinking, and it can grant you superpowers. I'm going to give you the key to those superpowers. Yeah. All right. Before we start, though, there's an anecdote I need to share with you, because it just blew my mind. I could not believe it. So yesterday, I arrived here on the Eurostar train from London. I arrived at Paris, Gare du Nord. Now, I studied French at school for about 7 years. I thought I knew French pretty well. But as it turns out, well, let's put it this way. A middle-aged man at the train station commented on the situation, saying, c'est ouf. Ouf, oh, what is this? So today I asked people, what does c'est ouf means? And their explanation, it made my brain explode. I could not believe what I was hearing, so I need to share it with you today. So French, there's this practical joke that I think they play on foreigners, which is le verlan. They just swap syllables around, because evidently French is not confusing enough. Evidently, for foreigners trying to learn French, it's not hard enough to deal with le subjonctif and ver, all meaning different things but being pronounced in the same way. So, yeah, that's my theory. It's just a practical joke that you play on foreigners, but I do kind of like it. So I did want to share it with you. Right, we've given latecomers a chance to walk in, so without further ado, let's start the presentation on l'arbre qui ne pleut. You see how confusing it is when people swap syllables for no reason? Right. In all seriousness, today's talk is going to start with a bit of motivation. Why care about polars? We'll then talk about expression plugins, a bit of motivation for why they are so awesome. I want to demonstrate to you then that they are easier than you might be thinking, and I'll demonstrate this by doing it in front of you, doing a bit of live coding. I'm already super scared, but you've already been laughing at my dumb jokes, so you seem like a friendly audience. That means we're going to do it anyway. All of my talks end in the same way, that is to say with some mixture of engaging Q&A and awkward silence. It's up to you how long each section lasts. Let's get this started. So first of all, why care about polars? So Polars was a project started in 2020, originally as a lockdown project, but in the past couple of years, it's really been exploding in popularity. So just to give some examples of people using it in production, G Research talks about how for them it's not just an improvement, it's a game changer. We see Sky talking about what it does to their processing times. We see Czech Technologies talking about how it saves them money on the cloud. NVIDIA giving a GPU engine to Polars, but most relevant today, the Double River investment hedge fund talking about how with the Polars plugin, they are able to get like much better performance compared to what they were doing previously with stats models or with custom Rust plus NumPy code. And today, you, yes, you, are going to learn how. So why care about Polars plugins? It's time for a super controversial question. And I don't mean controversial in the sense that I'm going to get code of conducted. I mean controversial in the sense that, well, you'll see. So, any French speakers in the house tonight? All right, quite a few of you. Okay, so if you are a French speaker, I'm now going to show you an image, and I would like you to shout out the name of this image in French, okay? Just shout out what you would call this in French. So on the count of 3, 1, 2, 3. All right, I think I heard at least a couple of answers there. And the reason is that it's a very controversial topic in France. What exactly is this? So with part of the country insisting that it's called chocolatine, and the rest of the country insisting that it's called pain au chocolat. And it becomes a source of regional pride. So I'm not going to attempt to settle this question today. We are not settling the question in this talk. But maybe we can make a Polars plugin which, given a city, can tell us whether people there are more likely to have a chocolatine or a pain au chocolat. Now, to do that, how are we going to do that? So we need to work with polygons. So we're going to use a tool to trace a polygon around the area where people call it chocolatine. Like this, we can get a list of coordinates. And then our algorithm is going to be something like this. So given some point, if the coordinate is inside that polygon, we are going to output chocolatine, and otherwise we output pain au chocolat. Sounds simple enough, but I'm not very good at geometry. So instead of trying to figure out myself how to do this, I'm going to look on crates.io. So crates.io, this is kind of like PyPI, but for Rust. Lots of very smart people publish very nice packages on there. And somebody published a nice package on geospatial primitives and algorithms, including points, line strings, polygons. Yeah, sounds like the kind of thing we need. So let's try using it. And we are going to follow the following 6 simple steps to make a Polars plugin. We are going to first use Cookie Cutter so that we start with a template. This gets rid of the boilerplate. We will then install Polars and Maturin, which are our dependencies. We need to write a bit of Rust code. That's the hard part and the part that I am most worried about. And then we need to register our Rust function in Python. Finally, we compile our code and celebrate, because congratulations, we've done it, we've got a Polars plugin. Right, let's see if we can do this. Enough presenting, time to live code. Super scared about this, especially because I'm going to do it in NeoVim, which I'm not very good at, but apparently it makes you look smart. So I need all the help I can get. So, whoops, what's going on? Not off to a great, okay, one sec, not off to a great start. Let's just, all right, let's try that again. Why is it now? Oh yeah, okay, sure. This is good. Somehow I've made some, I was so nervous I accidentally made a folder. Let's just get rid of that one. Okay, I think we're good. This is why we don't live code. Hopefully the rest of it is going to be a bit smoother. Right, so we've got 2 folders here I'd like to draw your attention to. So in Polars pastries, we've got our Python code, and let's already start compiling while I talk you through it. And then here in src, we've got our Rust code. So we've got expressions and lib.rs. So users are going to interact with Polars plugins from the Python code. So it's in here that we're going to have to start. So this plugin template comes built in with a function called pig-latinify. So let's take a look at it. Let's just see if we're able to execute it. All right, so all is good. I didn't mess up the template irreparably. So there's a file here called run.py in which we just make a toy data frame and then call the plugin pig-latinify on it. So what we're going to do today is we're going to modify our pig-latinify function with something called name pastry. And here's how we're going to do it. So it's going to take 2 inputs, which are going to be latitude and longitude. Then, so these are both into expr, which means something which either is an expression already, or it can be converted into an expression, such as a column name. Then, the rest is going to stay the same. We then go over to the Rust side, and let's see if we can do this. So instead of pig-latinify, let's again call this name pastry. Then, let's just check we did that. Yeah, we did that here as well. Okay, cool. So now let's get rid of this template pig-latin logic. And we're going to unpack the input. So first of all, we need to make our latitude. So latitude, that is going to be the first inputs. So inputs 0.f64 question mark to get out float 64 chunked. If you just listened to Joris's talk, you would know about arrow. Then inputs 0, let's replace 0 with 1 to get the longitude. And then we need to operate on these 2 inputs. And the way we do that in Polars is using a nice little convenience function, which Polars provides for us, called binary element-wise into string amortized. It's a bit of a mouthful, but it's a very descriptive name, so let's make sense of it. So binary element-wise into string amortized. What it means is it's binary in the sense that it operates on 2 inputs. So here, latitude and longitude. It's element-wise because it operates on each element 1 at a time, and it's into string in the sense that it produces a string, and it's amortized in the sense that Polars applies some optimizations to amortize the cost of repeatedly instantiating new strings. So our UDF, our user-defined function, we're going to first make a point using our variables x and y. We need to import point, though. And in Rust, we do that using use. So geo, we're going to use point. We'll also need polygon later, so let's take that now, as well as line string contains, and let's put a semicolon at the end. Let's save for good measure, and then this is going to have to be new. Right, then the algorithm is going to be as follows. We're going to have some chocolatine polygon. So like chocolatine, this is going to be some polygon. We'll define it in a second. Let's just take it for granted for now. And then if chocolatine.contains point, then we are going to write to our output buffer chocolatine. And otherwise, we are going to write pain au chocolat. Okay, there we go. Hope I spelled this correctly. Otherwise, I'll make people more angry than just by bringing up this controversial topic. Now, chocolatine isn't initialized, so we need to initialize it. So we're going to do that right now. So we're going to make a constant for this chocolatine coords. And these are going to be the coordinates of the places in France where people are more likely to have a chocolatine. So I pasted them here in plain text, so we can take them and then just paste them in. Let's get rid of this extra white space. Right, now in Rust, if you instantiate a constant, you need to declare its type. So this is going to be a two-dimensional array, and it's got 2 columns. How many rows does it have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so far so good. Let's go there to the comma. I can see a lot of red, which makes me a bit nervous. 11, and let's save. Okay, the red's gone away here. Then I think now we can instantiate our polygon. So polygon new, come on, we can do this. So line string from, we are going to use our chocolatine coordinates and convert it to a vector, because that's what this Rust crate wants. We then need to specify some interior points, and we don't have any interior points. We've just got some outer points, and anything that's inside for us is a, they call it chocolatine. Okay, what's up? What's going on here? All right, so instead of the colon, we need an equals. Yeah, looks good. So let's also put a couple of unwraps here so it stops complaining. We're creating these strings, so it's safe to unwrap. We know it's not going to fail. So to summarize, we are unpacking our 2 inputs into latitude and longitude. Cool. Then we are instantiating a polygon for the regions in France where they call it chocolatine. And then our algorithm is to loop over our rows, and then if for each row, the point that is defined by that row, if it's inside the chocolatine polygon, then we output chocolatine, and otherwise we output pain au chocolat. Seems simple enough. So now let's compile, and while it's compiling, let's go to our run.py file, and let's replace this pig latinify with name pastry. And let's get rid of that. So let's, whoops, I said get rid of it. So, sorry, not very good with Vim. So let's scan CSV, and let's go to my Scratch folder, where here I've got a file of French cities and their coordinates. And we're going to make a new column called pastry, which is going to be made using the plugin name pastry, which we just created. We're going to pass in latitude and longitude, and then we are going to, let's just filter. Let's only keep columns, rows where the population is greater than 100,000. Let's only keep big cities. Let's select then only the city and the pastry column. Right, this should be everything. Oh, let's just collect so that we can actually see the results. That should be everything. There's no way that this actually is going to work, but fortunately I've got some backup slides. So let's just go over what we are trying to do here. So yeah, scanning a CSV file, we're adding a new column using the plugin function which we just created. So as you can see, you develop plugins in Rust, but users just use them from Python. We then only keep rows with a population greater than 100,000. We select city and pastry columns and collect. Let's see if this runs. Run.py. So nervous. Okay, So as you can see, in Paris, people are more likely to, oh, thank you, appreciate it. Thank you. Very kind of you. So in Paris, people are more likely to call it pain au chocolat, but in Bordeaux and Toulouse, people are more likely to call it chocolatine. Okay, how are we doing for time? Okay, we're doing pretty well for time. So that means I can show you a few more interesting things. So one reason why I think Polar's plugins are so cool, they are super cool, is that they fit in perfectly with lazy execution. And I'd like to give a quick demonstration of what that really entails. Because you can see here that we are using lazy execution, like we're using scan CSV, this is lazy, but are we really making full use of lazy execution? So let's go back to expressions.rs and let's initialize a counter. So let's say let mut I equals 0, and then inside our loop, let's just increment I by 1. And then at the end, let's print out we completed this number of loops, I, and put a semicolon to keep Rust happy. Okay, now let's compile again. That's the thing with Rust, you're always compiling. But while it's compiling, we can do other things, like go to the run.py file and sneakily change this to eager execution. So let's do that. If we change this to eager execution, give it another second to finish compiling, get a coffee or something, yeah, do a Python side project. All right, yeah, Rust compilation times are a bit slow. That's the price you pay for getting such a good compiler. Okay, but then you get super fast execution, so it's a price worth paying. So now if we run the file, I want you to pay attention to this. It says we completed 627 loops. So we looped, in that plugin function, we looped over our rows 627 times. And that seems like quite a lot, given that at the end, we only had 40 rows of output. So let's try going back to lazy execution. Let's use that instead. And now, let's see what happens. Now it says we completed 40 loops. How is this possible? What kind of sorcery is this? What magic is Polar's pulling on us? So to answer this question, I'm going to have to go back to the slides. We can skip over the backup slides. Fortunately, we didn't need them. Right, so here's the part I wanted to show. So first, our function was called 627 times when we did it using eager execution, and then when we used lazy execution, it was only called 40 times. How is this possible? And the reason it's possible is because when you're working with lazy execution, Polars can sometimes figure out whether it's good to swap certain operations. Like if you're doing with columns and then filtering on a different column, then Polars can figure out, well, it's more efficient to first do the filter and then do the with columns. Yeah, so plugins like these do not kill query optimization. They slot in perfectly with lazy execution. Sorry, any chance I could get a glass of water somewhere? No, no worries. Okay. I'll see if my throat can make it. My throat dries up when I speak too much. Anyway, so today's example was maybe a bit contrived, but people have made Polar's plugins for all kinds of useful things, like distance metrics, data science, encryption, hashing, IP tools, ML, statistics, reverse geocoding, trading, and date times. And I hope that, dear generic audience member, this could be you. And if you want to learn how, then all you need to go to is this freely available online tutorial available at my GitHub called polars-plugins-tutorial, or use the QR code. And this can teach you how you can have a ton of fun, unlock super high performance, and impress everybody with your superpowers. Now, we've been through a lot today, so in confusion, let's go over it again. So Polars is a data frame library gaining a lot of traction. Polars can do a lot of things already, but it can't do everything. And so if there's something very customized which you want to do with Polars, but which Polars just doesn't have built in, then you can write your own plugin. Now, plugins are written in Rust, but users, absolute legend. Thank you so much, so kind of you. So plugins need to be written in Rust, but users can use them from Python. So your users don't need to know that it's a plugin, they don't need to know that it was written in Rust, they just use it just like they were using all of their other functions, no issue. We also saw how we could live code a plugin just here in front of the audience. And so I'd like to think that with this I got across the message that writing a Polars plugin is easier than you think. And we also demonstrated that plugins fit in seamlessly with lazy execution, and so Polars can figure out whether it's a good idea to swap certain operations. Because sometimes it's a good idea to swap things. Sometimes. Especially if you're in France and you want to confuse foreigners. Thank you.
So, thanks, Marco. Any questions related to, yes, I see one.
Thank you for a great talk. You showed us basically UDF functions that operate on columns. Do plugins also work on the whole data frame, and how that would interact with the library?
Oh, right. So the tutorial I've written exclusively covers expression plugins, but expressions can have multiple inputs. So you can make something that can consume multiple columns from your input. There is also a way of making plugins for I/O sources, so for reading from some unusual data format. Say that you want to make, I don't know, a SAS7BAT reader, but people from Polars don't want it to be in Polars itself. You can make this as a plugin. As for making something that operates on an entire data frame, like say you want to make a new kind of group by, I think for that you might have to just deal with it yourself in PyO3. But yeah, go to Choke's PyO3 tutorial to learn about how to do that.
Any other questions?
Really a question, but I want to point out, like, the way you presented the session, it was really nice. I mean, we are sitting in Paris, and whatever you said, like, make complete sense. Like, we had this poetic justice where you introduced the joke and then you explained the joke that should not have a confusion. And I like the fact that you gave a summary, because that itself solved many trivial questions that I might have had. So, I mean, thank you for the unique way of presentation. That's what I wanted to point out.
Okay. That's very kind of you. I mean, people think that I insert jokes into my presentations in order to amuse the audience. In reality, I just have a very short attention span, and usually I start with the intention of making a serious presentation, but then I get distracted and think, wouldn't it be funny if we did this? And then I spend all my time doing that, and this is the end result that you get.
Any there?
Hi, small question. So I like Polars, I think they're very cool, but as usual, I have a manager, so I have to convince him to use it in production. And obviously his first question would be, how complete is Polars when compared to pandas?
So being a replacement, a 100% replacement for pandas isn't an explicit goal of Polars. So there are things that Polars can do which you cannot do in pandas, and there are things that you can do in pandas that you cannot do in Polars. I think Polars covers a lot of ground. I know a lot of people now who are exclusively using Polars for their data frame processing. I did show today like a geospatial-inspired plugin, and to be fair, geospatial applications, they are not as complete in Polars compared to pandas, like not even close. GeoPandas is just like miles ahead of anything that's been done in the Polars space. So if you're doing geospatial analysis, it might be a bit difficult to convince your manager to move over to polars. If you're doing anything related to financial data, trading, I think you can probably cover most of what you need.
So let's say fintech, in that case, polars is fine, right? Because I'm thinking whether the perfect way of working on this would be purely in polars or to combine polars with pandas.
You can combine, yeah. It doesn't have to be like an either or decision that you only choose one and then you're not allowed to use the other one ever again. They have good interoperability. Polars has a from pandas function and a to pandas method on the data frame. So it's, yeah, perfectly legit to do your processing in polars as far as it can take you, then convert to pandas when you need to. You can be more effective by learning multiple tools and using them together than by swearing allegiance to just one for the rest of your days.
Right, thanks.
Okay, there is. In terms of when to use it, perhaps one last word would be if you're starting a new project. I think that's a perfect time to try using polars. All right, my friend.
So, I mean, it's a follow-up to his question only, since we are kind of weighing polars versus pandas. So, in terms of compute, is the polars data frame able to do the parallel, like, distributed processing, which the pandas cannot do?
So pandas itself doesn't do distributed computing. You can use Dask to distribute pandas. Now, polars does not, I'm not currently aware of a way to do distributed computing in polars, but you can get quite far before going distributed and using query optimization, lazy. There is a new streaming engine that will come out at some point, end of this year, early next year, we'll see. And that should allow you to really scale a lot better with polars. But yeah, if you really need distributed, then yeah, you might have to wait a bit before you can do this in polars natively.
Anything? Yes.
Sorry, another question. How much of Rust do you need to know to be able to write plugins effectively? Can you get it out with basically cloning everything, and or do you need to use lifetimes and more intricate Rust syntax? Thank you.
Fantastic question. I think if you just clone things and all you need to do is beat some Python, some like pure Python, looping over rows in Python kind of solution, then yeah, even if you clone everything, it's probably going to be better. I've got some benchmarks about this in the tutorial. If you want to do the best possible Rust, then yeah, you'd probably need to spend a little bit of time understanding ownership principle and lifetimes. But the amount of Rust you need, I think, is a lot less than most people expect. Like in the tutorial, there's a little section on prerequisites, including how to learn Rust, the basics of Rust that you need. So yeah, please go for it, and I'd be curious to hear whether that is indeed enough.
Okay. Okay.
How are we doing for time? Couple of minutes.
Thank you for the great talk. I heard that polars had a great way about managing time zone data in comparison to pandas. I was wondering the reason behind why is that, and how, to what extent it is more efficient than pandas. Thank you.
Wait a sec. Where did you hear it? Where did you hear this?
I think it was a PyData Amsterdam video that I watched.
Was it a talk that I gave?
Probably. I was watching it at 3 a.m. So.
Yeah. Yeah, I did a lot of the time zone work in polars. So the message that I have here is that if you have a niche interest that other people find boring, but you find it interesting, then that's your competitive advantage. That's how I got into contributing to polars. I don't know if it's necessarily that much better than pandas, but it is a lot stricter. Although pandas is also going in a stricter direction, like with pandas 3, well, you'll no longer like pass things with mixed offsets as an object column. But yeah, time zones, I hate them, but sometimes you just got to deal with them, and yeah, I think everything time series related in polars can be done in a time zone aware manner.
my closing questions. Is there any tools to write agnostic data frame code?
All right, well, maybe I can get back to the question about is there a way to distribute your Polars code. And I don't actually have a connection to Wi-Fi, so I can't show you in the flesh. But I do have a little tool called Narwhals, which with the Polars API can dispatch to different backends, including Dask. So if you want to execute Dask, but you prefer to write Polars syntax, then maybe give Narwhals a go. And if you don't want to give it a go, then please give us a star to boost my ego.
Okay. So thank you, Marco. And we can, again, upload you.
Thank you, Guillaume. Thank you, everybody. You've been so kind. You've been so amazing. Thank you, everyone. Good night.